lovely students. How are you? I hope you are quite well and your studies is going very fine. This is lecture number 14 of aldehydes and it is chemical properties lecture number 4. So today we are going to discuss the ammonia derivatives, means the additions of ammonia derivatives in the carbonyl compounds. Students, we are going to discuss with the mechanism and with the examples so that I hope you will understand perfectly. Student, despite being any doubt you have, you go in the mail sections and any doubt you send me. I will mention your doubt in the next video lecture. So let's proceed the topic. Students, so I write the heading here. It is addition of ammonia derivatives. Addition of ammonia derivatives. And so what happened, students, the ammonia derivatives follow the mechanism addition, nucleophilic additions elimination mechanism. It follow the nucleophilic additions eliminations mechanism. You will understand as we proceed the mechanism. Then you will understand why I am telling you that nucleophilic addition elimination mechanism. First, second is that it should be in a weakly acidic medium. Weakly acidic medium. See here, student, any aldehydes, either aldehydes or ketones, either aldehyde or ketones react with 1 degree amine, form amines, that is also called CIPS base. Student, you know, the CIPS base is used to distinguish between aldehyde and ketones. So that all aldehyde gives the CIPS test. Now let's understand through the example. See here, students, what will happen? Suppose CH3 C double bond O H you have and react with that H and HR, and what will happen? It will form the CH3 COH, correct, H and N, H and R here, right? And this compound, and then heated, when we supply the heat, then this compound is going to be formed a water loss, and it is formed here that the CH3 CH double bond and HR, right? So this is called LD mines. LD mines. What I'm telling you, what is called? This is called LD mines, and it is an amino alcohol. This is called amino alcohols because OH group is there. So you can write exactly same product in the simple way. But why I have written, you will understand here. We can write in a simple way what CH3H and H2N R is there, right? So what is going to be happen here? OH and H will remove, then there is no H here, then here will be no H strength. So what is going to be here? OH2 will loss, and the compound is formed like that, CH3H double bond and R. That is the CIPS base. Still, all ammonia derivative will be the EZ configurations. EZ configuration, you remember that? CH3H double bond and lone pair and the R. So it will behave like EZ configuration. So all ammonia derivatives will behave like EZ configurations. Okay. So this is the, since aldehyde is reacted with the 1 degree amine, so it is LD minus. When we'll take the ketone, let's understand to that ketone example. CH3, C double bond OCH3, and that is the R NH2. Okay, 1 degree amine here, and what will happen? That will form the CH3, COH, CH3, and NHR, and amino alcohols. This amino alcohols is heated, the H2O is lost, and what will happen? C, CH3, CH3 double bond, and R will form. Since we have taken the ketone, so it will form the ketomines, correct? So I have taken the ketone, then form the ketomines will form. Now, students, one thing is that I have written in the above, you can see here, weakly acidic medium. So why I have written the weakly acidic medium? And why I have written nucleophilic addition and then eliminations? Eliminations is okay, because you can see here, loss of water is the eliminations. But rest two things you will understand through the mechanism here. So let's understand here. C double bond O compound, C double bond O I have taken, which have there is a N, H, and H lone pair. There are is. So what happened? This nucleophile, because lone pair is there, that nucleophile is going to attack on the carbonyl compounds that we will remove here, which will proceed like that: C, O negative, N, H, HR. Now here is the what happened. This compound is that going to be dipolar intermediate. This is the dipolar because here is a positive charge and negative charge. So dipolar intermediate is formed. Student, this dipolar intermediate is the internal proton transfer will be happened, and this hydrogen is coming here. This is called internal proton transfer. So internal proton transfer will happen, and the compound is going to be C N H R O H. Means amino alcohol is there, correct na? So what happened? Amino alcohol will form. Now student, at this point the amino alcohol is going to be formed. Now amino alcohol, now amino alcohols, what will happen? Now this amino alcohols, when reacted with the acid, we have taken the acid. So why we have taken the acid? Because acid will react with the OH. OH is a poor nucleophile. So this acid will generate a good nucleophile from poor nucleophile. OH is the poor nucleophile. So H plus will generate a good, OH is the poor leaving group. Sorry, OH is the good nucleophile. OH is the poor leaving group. So OH is the poor leaving group. H plus will generate a good leaving group. Correct? So C, N, H, R, OH, and H cations. Now that will remove, and the water is lost, and that compound is going to be formed like C, cations, N, H, R, and lone pair. This lone pair will form a double bond. You can see here C double bond N, H, R. Correct? Right? So these things will form. This is ammonium ions. Here is that these things is going to be formed like. So when the lone pair will donate to the nitrogens, then this is called, what we'll call, ammonium ion. This is the ammonium ions. This ammonium ions, when react with the acid, I take here acid, HA. So what happened? That is going to be, or simply, here is a compound is going to be formed like that. And this compound, what will happen? We have taken the water again. So H2O, H2O is a lone pair, contains lone pair. So that water take the hydrogens and neutralize the charge of nitrogens. So what happen? C double bond N R and lone pair will regain these compounds. So as you know, it is a EZ configuration. Earlier I said in the mechanism you have through the mechanism, what we can say here. If I take here excess of H plus ions, then what happens, students? This H plus, as you know, ammonia is a base and ammonia derivative is also base. So ammonia, if we take the acid excess, if we take this acid excess, the ammonia or its derivative will combine with the acid and form the ammonium salt. So reaction will not occur, first of all. Second, if H plus will not take the optimum range, then this OH will substances which is a strong nucleophile cannot leave these positions. Since it will not leave the position, so it will not form the ammonium ions that will not form the ammonium ions. Hence, reaction will not be occur. Or you can say that reaction will move very slow. So therefore, the optimum pH is 4 to 5 for this amine formations. Correct? I hope you understood it. Now we talk about enamines. What we talk about? Enamines. What is enamines, students? Enamines is either aldehyde or ketone. Either aldehydes or ketones react with 2-degree amines. 2-degree amines forms enamines. Okay. Now see here what the enamines is. But the one thing is that enamines, any aldehyde ketone of course have, but aldehydes should have alpha hydrogen. See what I am telling you, that the C, here is that C double bond O, H, there should be alpha positions. Why I am telling you? Because their mechanism is totally different from the amines mechanism. So student, what is going to be happen here? When we'll take the H, N, R and R, the compound is going to be formed here. C double bond C, N, R and R will form. This is called enamines. One more example I give you here. Here we'll take the CH3, correct? CH3 and CH3 C double bond OH, and we'll take that H and R. So what is going to be formed, students? 2-degree amine I have taken. So what will happen? That will form the CH3 COH, correct? And H and R and R. We will understand through the mechanism what is going to be happening. So when the heat is supplied, OH and from the here H will loss and the compound is formed CH2 double bond CH and then ion R or R. Okay. So this is called enamines. Enamines. Okay. Okay. Let's understand through the question mechanism. Then one more example I will give you. Here is that mechanism is that suppose you have that CH3 C double bond O H strands and we have taken the N R and here is the hydrogens lone pair. The lone pair is going to attack here, that will transfer that electron towards the oxygens and then its compound is going to be formed the C O negative, correct? It is the hydrogens N H R and R and this here is that intermolecular hydrogen will transfer here, intermolecular proton transfer. Okay. So intermolecular proton transfer and the compound is going to be formed here, amino alcohols, that the CH3, 2 hydrogens, 3 oxygens, 3 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 hydrogens, 3 o CH, OH, N, R, and lone pair will come. Now the point is, when we supply the heat, the compound is going to form, water is lost, and it will form the CH2 double bond C, correct? Hydrogens, and N, R, and R. It is lone pair, right? So these things is going to be formed here, or simply you can see here before that loss of water. Before the loss of water, what is going to be formed, students, here? Before the loss of water, see here, uh, before the loss of water, one things will happen here. See what happened before the loss of water. That is the, see here, that when we take the acid Ha, that acid, the base OH minus will take these hydrogens, and what happened? The compound is going to be formed here, that the CH3 C, okay. So because this hydrogen will take that oxygens, and the compound is going to be formed like that, CH, and single bond here is that C, and cations will form, and here is the hydrogens, N, R, and R will form. Okay, so here is a lone pair. That lone pair will be given to the carbons by the nitrogens, and the form that CH3C, H double bond, and R cations will form. So how to stable it is, compound is becomes unstable because nitrogen contains the positive charge. So what things is going to be happen here? Now you have that when this anions as a base, this negative charge attack on the alpha hydrogens, and where is the alpha hydrogen, students? Where the that will attack, because C double bond N is that form here. So when we write here this compound like that, CH2H, right? C double bond N, R, cation is there. A minus, it will take these hydrogens, the negative charge here. So CH2 contains the negative charge, then C double bond N, R, and R. This is positive, so it will transfer here, and what happened? The positive charge will come, and the compound is going to form CH2 double bond C. Don't forget here H is there, so N, R, will form. So this anion charge will neutralize the positive charge on the nitrogens, and the enamines will form. Enamines will form. Okay, let's understand through one more example here, then you will understand perfectly. See here what the example is. The compound is that here is that CH3 CH2 C double bond OCH3, okay, and R and R and H is there, lone pair, that will attack here, and the compound is going to be formed CH3 CH2 and COH CH3 and, correct, directly, see I have written here directly what I have written, that the OH is there, O negative, H, R, and then the proton is going to be transferred here. So that things will happen, that the CH3 CH2 COH and R will form. Correct, negative charge will come here again, and then we'll take that directly I write here, because mechanism already we have done that. So the possibilities is here. What the possibilities is here? So this H or OH will remove. Second, OH and hydrogen from this carbon will remove. So what is going to be happening here? CH3 CH double bond C, CH3 and R will form. Second, since the lone pair is there and OH is removed by the acid, then the positive charge will come here. So one more possibility is there. that the possibilities is CH3, CH2C, CH3, double bond N, R and R will form. Third possibility is that CH3, CH2C double bond, CH, CH2, okay, and N, R will form. Students, second and third. See, student, according to that, logically, the more alpha hydrogen here, that should be the actually it should be more stable. Actually, it should be it should be more stable. Correct? Actually, it should have there is this compound because contains the more alpha hydrogen. So, but the logically, but this compound is going to be more stable. Why? Because the Hoffman product will form. The compound is going to be the Hoffman product will form. So the hops, it is a major because the Hoffman product will favor these compounds. This elimination will favor the Hoffman product. So that is the more stable. Third is the more stable compounds. Okay. I hope you understood this whole logic, students. Now we talk about see that we have done the enamines, we have done the amines. Now we'll talk about oximes. Oximes, see students, whatever compound you have that the H2N OH, this compound is going to be oximes. So OH2 will remove and the compound is formed double bond N OH. Similarly, if you have taken the phenyl hydrazine or hydrazine, so H2N NH2, this is the hydrazine. So OH2 will remove and the compound is going to be formed like that NH2. Correct? Yeah? So similarly, you can take the phenyl hydrazine also, H2N, NH, and phenyl, and the logic is going to be formed, the compound is formed, the OH2 will remove. So this is the NHPH. Now, we talk about the O put 2,4-DNP, H2N, right, NH, and here is a benzene and NO2, 1, 2, 3, 4, NO2, that is 2,4-DNP. This 2,4-DNP is called, students, Brady's reagent. Brady's reagent, which will form that OH2 will remove and the compound is going to be formed NH, and here is the benzene NO2. NO2 is going to form. This is the orange. This is the compound is going to be formed, that orange PPT like that. So what happened? Solid orange PPT. Solid orange PPT will form. Okay. So this solid orange PPT is enough to distinguish between that whether this 2,4-DNP will confirm whether the carbonyl compound in the solution or not. Hence 2,4-DNP is used to distinguish between the carbonyl compound and other, because aldehyde ketone both will give 2,4-DNP test. Okay, right, students? Let's understand one more example. A plus B you have, and the compound is going to be formed here, that the N lone pair and OH is there. Can you tell me what the A or B? I write the options. PH, CH2, CH double bond O plus H2N, OH. Second is that PH, C double bond O, CH3 plus H2N, OH. Third we have that the PH, C double bond O, CH3 plus NH2. And fourth we have that the pH and here is that pH C double bond O H plus NH2OH. What do you think, student? What option is going to be the correct? It looks like you can see here this mechanism, these reactions. So your options B is that correct options. Correct, na? So I hope, students, you understood the whole logic of the amine derivatives. Thank you very much. Have a nice day.